Quick show of hands, who here considers themselves a data architect? Okay, how about a data scientist? How about an application developer? So quite a mix. Who has never heard of polyglot persistence before? Okay, so I'm going to explain what this mouthful is and what multimodal databases are, and give you some side-by-side pros and cons, and leave you without a definitive answer, but hopefully with a much deeper understanding of how to apply what where. And pretty much everything Richard just said applies, because I'm going to be talking more about the technology in the data stores themselves. And Dino already introduced me, so I won't belabor this, other than to say I worked at Microsoft, and during the time that what's now CosmoDB was coming into form, it was called DocumentDB and focused on unstructured data at the time. And I joined a company called Intersystems only 3 months ago, long after I had submitted this presentation. But ironically, what Intersystems does is we provide a product, a data platform, which includes interoperability, a multimodal database, a bunch of integration tools, but not so much the visualization. And we focus on healthcare. We also provide applications built for things like information exchanges in hospitals. So let me go through the what and why of these terms, give you a side-by-side comparison. There are some points of intrinsic difference or controversy, and then wrap up. So this is a map from the 451 group last year of the database technologies available on the market. And since this map came out, there have been another 14 new entrants. We live in an amazingly dynamic time. If anyone ever told you that databases were all converging on the majors, that was probably about 10 years ago. When who in the world would want it to make another database company? Now they're growing like crazy, and the cloud vendors, what I call the software superpowers, are all providing new applications. It's very confusing because it's moving so fast and because there's so many choices. And at a very high level, among the 5 or 6 or 7 V's, like the velocity and volume and veracity of data, the variety of data also means there's a huge variety of data models. And data stores have tended to specialize in one of these data models. If you grow up as Oracle with a world of tables and a mindset of relational databases, when you meet a graph, you're going to try to stuff it into a table. And you'll end up with a SQL graph query language. If you grow up as a graph store like Neo4j, and you meet a document, you're going to say, I'm going to shove that into a graph. It's not intrinsic, it's what is the law that software architecture tends to resemble the organizational structure within which it grew up. So one thing that's useful is to just think about the different models and the heritage of the data store. And to a basic level, the data complexity and the relationship complexity give you a sense of where things lie. The trick, of course, is that any complex and interesting application uses multiple models. And you, as a data architect, have to think about which models to use where and how they relate. Did I lose the? Yeah. I lost probably the battery in this. Is this mic live? Yes. Okay, so I won't walk around quite so much. But, and there's a lot of great material about this, including books on data modeling. This is a classic example of airline fleet management that was presented at the O'Reilly conference last year, and there's also nice code samples associated with it, where you can understand why you need multiple data models, right? Each part for maintenance has lots of different attributes that are not the same. So making all the attributes, okay, maybe size, dimensions, length, height, width, weight are common, but almost everything else is unique to that part. Doesn't fit a table so well, fits a document model pretty well. The relationships between things and the talent of who knows who and what they know fits a graph, et cetera, et cetera. So at some level, almost every complex application, every application that matters, has multiple data models beneath it. And you may be modeling them together when you get far away, when you try to get far away from your native data model, it just sort of feels like there's more friction. From this, there's an idea called polyglot persistence. And if you're an application developer, you'll have heard of polyglot applications, which is the equivalent in using multiple languages for an application. This idea is simply that you're using multiple data stores, picking which data store works for that part of the application, and then gluing it together. And this dates, at least as a term, back about 12 years, when the rise of NoSQL databases came. Also came this, hey, I need different things for different purposes, but I have to stitch them together. And almost any time you are doing data integration, even if you're working in data warehouses or connecting data lakes or data swamps, however you prefer to call them, along with a analytical reporting workload, you are stitching together multiple data stores. And this kind of picture, which is just an operational database that has reporting. So the traditional, what are called HTAP, hybrid transaction and analytical processing, many people have implemented as multiple databases with copies of the data between them. So that's what polyglot persistence is. Multi-model is simply the idea that you can take one data store or one data store stack, sometimes different instances, and use it with different models on the same data. So for example, take something which is a document store and present it as SQL for reporting. Or have something that does both graph relationships and table relationships along with the same data. And this is, as a term, yes?
So you're saying that the first one, polyglot, means you're actually literally storing the different models and tracking them in parallel, separately stored,
yes,
somehow made consistent with one another. And the second, you're storing one back end and serving that all these different models out of it.
Exactly.
So that's your question is which way to go?
Which way to go?
Okay.
And you got it. And that's the rest. We're going to do another 20 minutes on this.
Go ahead.
But at a virtual level, it's the same. The same basic idea. If you're doing data modeling, you're building an application, you're using multiple models at some level. And the question is whether your technology stack stitches them together behind the scenes, or whether you stitch them together, or whether it's a unified story. Does that make sense?
I understand.
Okay. And the basic idea here is that you'll have multiple models and they're all in one product, in one stack. This was a great paper that also came out in the Enterprise Database Journal in December, which sort of gives you a history. If you like being a historian, uh, this is not really a new concept. Back from the 90s, when there were object databases, the object database world sort of thought this way, that everything is this abstract object and you can look at it with different views or different ideas. And this basically takes the different heritage of different databases and talks about when they've added multiple models. Doesn't mean that they've added all the models you need. And I'll talk more about that. But it gives you a sense that this is not a brand new world. So let's talk about side by side the difference between Polyglot and multimodel. And I'll use an example application which is pretty pedestrian. This is a hotel booking like hotel.com. And even within that web application, in addition to the BI or presentation layer and the application user interface layer, at the data layer, there's at least 5 different kinds of things that you want to do with data that have sort of a natural model. Recommendations are naturally this fuzzy concept where you're taking and doing matching and like to be in a graph database. Whereas financial data tends to like to be in a relational database. So if you were to build this application and use Polyglot Persistent, you've got 6 different kinds of data stores. And there are lots of systems in the world that are built this way. Each of these you then pick up, you work on this part of the system, and you stitch them together. And the basic trade-off here is between a polyglot pattern, where you're using, in this example, 5 different data technologies, or something that gives you a single data store that somehow lets you work with all those models. And that's a really simple at a high level. If you've got 5 different things, they're more complex. If you've got one thing, it's less complex, but the question is, can it actually do the job? What are you giving up? And I'll walk through different elements of that. First of all, what's the level of choice you as an architect or as a application developer have? In the polyglot world, the area of specialized data stores, you have an enormous amount of choice. I'm not a big fan of DB Engine's ranking because it's all based upon popularity, but it lets you, so it's like, I never won the popularity contest in high school, let me put it that way. But there's 342 databases listed. You got a lot of choice, and there's advanced features in some of those that are pretty cool. In the multi-model world, it's relatively new. Right? The concept sort of dates back about 6 years. In the last 5 years, you've seen a lot more press about it. There's a lot less choice, and each one of those may not have all the features. And this DB ranking doesn't separate multi-model. This is a list of the current multi-model things that are on the market that really cover, I'll say, more than 3 models in a decent way. So it's not that big. There's maybe 10 choices, but it's big enough that you really can do this as you get familiar with them. Now, from a systems standpoint, if you're a system architect and you're thinking about nodes and boxes and cloud deployment or how many containers you have or this kind of thing, the complexity of dealing with multiple stacks is an obvious detraction. And when you try to get a highly available system, even more so. And in scaling up, each of these things scales in its own way, independently, which you might think is an advantage, can be an advantage in some ways if you have only one kind of data that's massively scaling up or down. But you don't get to pool across these different kinds of data. So multiple data stores gives you more complexity. if you're in a high availability environment, some of these use mirroring techniques. They work in pairs. Some of these use clustering techniques or Zookeeper. They work in triples or more. And there isn't something that gives you a controller across all of them. So you're essentially providing HA clusters or mirrors for each of them and then putting an application on top of them, and that application also has to be highly available. You get a pretty complex picture. As an application developer, there's a need to synchronize data. If you have data in multiple stores within your application, it's not completely independent from each other. There are relationships between the data or else you wouldn't have it, which means there's some duplication and some synchronization, and that adds complexity. And you also have to be attentive to the design of each data set and think about where you're going to put, what kind of model are you going to use for what kind of data. It's quite possible, this is a pretty standard technique, but it is much more complex. And the ETL or API interoperability integration that Richard talked about, I think is the complexity and the heavy lifting of that is, I think, is understated. There's a lot of work involved in data transformation and data synchronization across stores. So if you can avoid this, if you can avoid this, you want to avoid this. Sorry about this. I keep thinking I might. And this is, this slide is courtesy of MarkLogic, which grew up as a Sparkle, essentially unstructured data store, and is now one of the ones that's a multimodal database. If you look at the application, you are stitching together in your code different data models and where you keep what. So in general, polyglot persistence gives you a huge amount of choice. It also gives you more complexity. And it isn't like, I'm just going to use polyglot. You have to think through your data model specific to the application and often specific to your organization. Economically, the additional copies of things for polyglot tends to be a disadvantage, both in terms of licensing, maintenance, as well as learning each of these stacks, because it's easier these days to use different technology packages. You can download open source and work with them, but you still need to learn them. And we did an interesting thing with MIT about 4 months ago, which has now been published as a paper, and sponsored a application for their sustainability labs, but had 2 different groups build it, like a bake-off. One of which was using polyglot persistence with open source, one of which was using a multi-model database. Now, I can't tell you that these are the skill levels of the groups were highly calibrated and we did this as a deep scientific experiment. This is marketing from my company. But it's, I think it was a pretty honest attempt at doing side-by-side comparison of how much work does it really take to build a moderately complex application in these 2 things. And there's a big difference. I mean, the actual time in hours to research tools and figure out what you're going to do is probably the biggest one. Is that now got batteries? Okay. Whereas the development cost was a pretty significant difference, not even counting maintenance. And this also counts from a TCO. It counts open source as free. And most people who use open source want to pay for maintenance. The last element I'll talk about side by side is performance, because this is the key thing where your mileage may vary. In a polyglot environment, many of these data stores are really highly performant at the model they're built to cover. And where multi-model gains an advantage is that once you've cached something, you've cached it once across all the models. So in a real application, often you see these bake-offs where multi-model wins because it doesn't try to move data back and forth between multiple stores and because caching is a big win. So it depends. If your application is relatively simple, actually things using a polyglot thing can be faster. If you're looking at user caches, and Redis is really, really quick if you don't need durability. But if you have a complex application, often you'll find that that's a win in multi-model as well. So I said I wouldn't give you a definitive element. This is a scorecard with bubbles, which is definitely weighted towards the multi-model side, which is just a takeaway for you about what to look at, that it's a genuine option in a way that really wasn't 5 years ago. So we talked about the side-by-side comparison. Yes?
So when you say the word persistence, you say polyglot persistence. Persistence is focused on keeping the multiple models consistent with one another, or why do you say persistence?
Persistence is simply mean that you're storing data,
Okay.
right? It's nothing more than that.
Each is independently
Right.
stored.
There is polyglot programming, there's polyglot persistence, and it means that data is kept persistent in multiple places. So there's two basic things which are arguably intrinsic. One is that one size does not fit all. And you heard this from Richard. You heard a little bit about these trade-offs in the keynote this morning. And I think this is in fact intrinsic, that one size will never fit all. The question is, what is the cost of the trade-offs? How much are you giving up? The other is a pendulum or a debate that continually goes in technology between the general purpose and the specific and the special purpose. And there was an era where there was special purpose computing that then went away because the economics of general purpose computing became favorable, which then swang back towards GPU kind of architecture. So this is really more about economics than intrinsics. But I'd also say it's true. Something that you've built for a special purpose will always be better than something general purpose. It's just whether it's worth the money. I'm fond of saying in software there's no laws of physics, there's just laws of economics. Who has heard of the CAP theorem? Okay. My graduate work was all in theoretical computer science, so I gravitate to this kind of thing. This is something which was first put out as a conjecture by a guy named Eric Brewer around the turn of the century, and actually proven by one of my professors, Nancy Lynch, in 2002. And the basic idea is you're going to put out a system in a world where there are failures. And given that there are failures, partitions, network partitions, there's a trade-off between how failure tolerant you are, how available you are, is it nonstop, or do you have to recover, and how consistent the data is. So you got 3 areas, pick 2. It's sort of like in project management, where you have time, resources, content, pick 2. So this is often used as a way, especially in NoSQL, of making the case that you need multiple data stores because they have multiple points on this curve or on this triangle. And you can see different families of things designed for different trade-offs between these 3 points. Now, I will say that in the 16 years since the CAP theorem was proved, there have been a lot of critiques. I think it's still intrinsically interesting, but from a pragmatic standpoint, even Eric Brewer 3 years ago came out with another paper saying, yes, I know I proved this, but here's what I really mean and here's what happens now. A lot of this is too simplistic And in a real world, often you're only choosing between availability and consistency when there's a failure. So that's why there's a difference between high availability and disaster recovery, for example. So the takeaway from this is there are some intrinsic trade-offs. You really still need to know from your application standpoint what kind of availability you need, just like you need to have a data architecture. But this is overblown as a case for polyglot persistence. The other case is often about performance. And this is remember I said that the big difference with performance is caching and intra-system latency. Well, actually, a lot of the more modern data stores on very basic benchmarks, like read, write, recall, search, can be really competitive. And this is, as of started being the case about 2.5, 3 years ago. This is from ArangoDB. It's a pretty good multimodal database. And they're green versus Neo4j or MongoDB on basic down to the metal elements. So you can actually get the capacity for being multimodal without necessarily giving up much on basic performance. I will leave you with, in this, my side-by-side showed heavily weighted towards multi-model databases, with the main difference being that these are still a special breed and you have less choice. These are not all the same. Right? There's multi-model things such as Microsoft's Polybase built into SQL 2017 is actually Polyglot, and they're not transparent about it. Right? They say it's Polybase. Oracle's multi-model is actually Polyglot under the hood. You need to make multiple copies of the data to use multiple models. It's what's called stacking. And what you'll see, I think, in the future is more of this multi-model. This is a Gartner market clock. If you've never seen this, it's yet another way that analysts prove their value by putting out something that's confusing to interpret. The way you read this is there's some sort of invention of new things that give you some potential advantage that get extremely highly hyped, things like blockchain. And then you start seeing standards, you start having a choice of things, and then it comes down to everything's commodity and you're competing on cost, and then things are obsolete. XML databases are no longer something you would pick. And this shows multi-model databases as just having crossed the dawn of standards with a very quick time to standardization. So it's basically a statement by Gartner that these things are now on the market, there's multiple choices, and they're developing quickly. There's 6 basic challenges, and I'm out of time to walk through them in terms of future directions. But these are the things I would keep your eye on if you want to follow this space. There's no standards for queries that work across all these models. You end up with, Tinkerpop and SQL Graph and Sparkle, which is, you'd like to be portable and write something that works on all multi-model databases the way you can sort of write something that works across SQL databases. We're not there yet. And you'd like to be able to do transactions at very high scale that go across multiple models. We're not there yet. So these are really the 6 challenges. They're active research. And this is a great paper on the research principles for multi-model. But what you should take away is that we weren't talking about multi-model databases 5 years ago, and we're barely talking about them 3 years ago. There's a big wave towards the general purpose across multiple models. And we've talked about what and why, side by side, the future. These really are aimed at the same problem. And the main disadvantage today for multimodal is limited choice. That's it. Thank you very much.